This video will explain what we mean by the extended definition of trigonometric functions. Another way of putting that is how come they seem to be defined for triangles and then they just seem to be defined for circles? I don't understand. So this video will explain the ideas behind that. First, what you learn in geometry class. What you learn is very limited. It's limited to right triangles. This is a very familiar idea. Right triangles has a right angle. That creates the long side opposites called the hypotenuse. Then you pick one of the two other angles, and we'll call it theta. Pick one of the two other angles, and that immediately names the two shorter sides. The side touching theta is called the adjacent side, and the other one is called the opposite side. And then we define the sine ratio of theta. That's the full way to put it. The sine ratio of theta as the ratio of the opposite side to the hypotenuse side, written as a fraction. In other words, opposite over hypotenuse. Likewise for cosine. Notice the three lines here. That means equals, but it also means it's a definition. It's drawing your attention that this is a definition, something that people made up. Sine of theta is defined as this. Okay, this is what they teach you in geometry, and in a way it can cripple you for later. And I've asked students, like, what does sine mean? And they'll say opposite over hypotenuse. Nope, that's only true if it's a right triangle. There's an extended definition that we'll get to in a second. Here's why this definition was too limited to last. It is an old one. It's the original one, but it's too limited to last. The reason is, if you graph like y equals sine of theta versus theta, you get what is a nice promising shape. It can't be zero. Like, you can't have a zero adjacent side, then you won't have a triangle. You get this nice curve here, and it can't be 90. So at 90 degrees you have an open circle. Okay, that looks like the beginning of a very useful shape, which has all sorts of applications. A very useful graph has all sorts of applications in science and engineering and math, but it's only part of it if we define sine and cosine this way. So we need to extend it. Another way of phrasing the problem is, what if theta is less than or equal to 0 degrees? You can't use the triangle definition. Or what if theta is greater than or equal to 90 degrees? This definition won't work. Okay, so the definition is extended. Extended definition. Okay, this was done later, and you normally learn it like at the end of geometry or algebra 2, and you have to, the key to this is you have to forget right triangles. Forget what you learned in geometry as being like what sine and cosine really mean. That's not what they really mean. That's like a limited view, and now you take more advanced math and you see the whole picture. Okay, the extended definition is based on circles. So what we do is, it's actually based on a circle superimposed on coordinate axes. So we draw a familiar coordinate axes with x and y coordinates, x and y axes. Then you draw a circle. At first, the circle can have any radius you want. And now you decide what angle you want. We can start in quadrant 1, so we can start with what looks like a regular right triangle. So we'll draw this, okay? That'll be the hypotenuse. And the hypotenuse always goes from the origin to the circle. So that means the hypotenuse is also the radius. Okay? That creates a dot on the circle itself. That dot will have coordinates, which will be x comma y, of course. Okay? Now something very special happens if you then complete this, like make this a right triangle with an opposite side and an adjacent side. Okay? I like to use those colors, blue for x direction, red for y direction. Okay? And then this here being the theta. So actually at first it looks just like the triangle we had on the previous page. But notice what's going on here. This dot on the circle that the hypotenuse reaches, okay, that dot has two coordinates, x and y, and the x coordinate is right here. And that's also the length of this side because it starts at 0. So so the adjacent side of this right triangle equals x. And likewise, this height here is y. There's the y coordinate, there's y. So the opposite side equals y. Okay. So from that, look what happens. Sine of theta is is opposite over hypotenuse, but the opposite side is the same as the y coordinate, and the hypotenuse is the same as the radius. Likewise, cosine of theta is adjacent over hypotenuse, but the adjacent side is the same as the x-coordinate of that dot, and the hypotenuse is the same as the radius. So now we'll get what we'll call the extended definitions of sine and cosine. Sine of theta is now defined as y over r, and cosine of theta is now defined as x over r. This is the real definition of sine and cosine as they are used in the real world. Okay, not the little right triangle one you learn in geometry class. So you have to think of this now as sine and cosine, and we'll make it even easier in a second. Okay, the advantage of this is that x and y, the radius is the radius, that's a number anywhere, and x and y have values through all the quadrants, positive and negative numbers. So we can make theta now bigger than 90 degrees. We can even make theta negative. So we'll do a couple of examples with that. Okay, and you should sketch, like as often as you can when you're talking about these things, do this sketch that I'm doing now, because it gives you practice and confidence and realization, oh, I can get quick estimates of sine and cosine anytime I want by sketching a circle and axes. Okay, so let's say we want to look at 120 degrees. That would be about to this, 120 degrees. So theta equals 120 degrees. That creates a dot on the unit circle. The length of this will be r. Okay? That dot has coordinates x and y. So that dot has coordinates x, comma, y, comma. And as soon as you think that, you should start asking yourself questions. Before I ask any questions, you should start asking yourself questions. Let's say, oh, that coordinate, is either one of them negative? Which one's bigger? That sort of thing. Okay, so the y coordinate of that dot is here. Okay, that's y. And the x coordinate of that dot is there. Okay, that's x. Okay, now consider our definition on the previous page. Okay, sine of theta, so sine of 120 degrees equals that value of y divided by that radius. And if we drew this very accurately, like with a compass and a protractor, and measured it with a ruler, okay, we would find that that value is about 0.866. Like if we measured that length for y and measured that radius, and it actually looks about right, about 0.866. And that's the sine of 120 degrees. Okay, rounded, of course. Okay, so the cosine of 120 degrees, we would get that by measuring this length and dividing by that length. We could do it with a ruler. But notice, look at the x-coordinate. Is it positive or negative? It's negative. So we would get, if we measure that, we get negative 0.5. And it looks about right. That looks like it's about half the length of the radius. So even just a rough sketch by hand, we can get pretty close. And if you draw it very accurately with a ruler, you can get very good results. Okay, we're going to make this easier now. So this will be the last topic on this video. 1, 2, 3. The unit circle. Okay, so recall from the previous page, if you draw a circle and you can measure the radius and the x and y coordinates of any dot on the circle, then the sine of theta is defined as the y coordinate of the dot over the radius, and the cosine of theta is defined as the x coordinate of the dot over the radius. And now think, you could draw circles of any size, small, big, and use your ruler and whatever. What would be the best possible radius? What would be the easiest number to divide by? And so we'll put that this is easiest if we draw a circle with a radius equal to 1. Well, of course, we can pick whatever units we want to use to make the radius 1, but the basic idea of the unit circle is the radius is 1. That's why it's called the unit circle. Unit, and it's a good idea to know what words mean if you're going to use them or read them or your teacher uses them. Don't let them sort of pass by you without knowing why. Why is it called the unit circle? Okay, because the word unit comes from a Latin word that means one. Okay, and you can see this in uno, une in French. The word unity in English has to do with one. Even the word one, you can kind of see a connection. Okay, so the unit circle is a circle with a radius of 1. Now watch what happens if we make the radius 1. Once again, all we have to do is rough sketch. X, Y, here's a circle. And now the radius is 1 instead of R. The radius is 1. Okay, so let's say we pick an angle. Let's say this is about 40 degrees. We pick a dot like that. Okay, that dot will immediately, see your angle is created by a line from the origin to a dot on the circle. So 40 degrees is the same thing as giving the coordinates of this dot. The dot creates the angle creates the dot. So you only have to give one or the other. So the coordinates of this dot are x and y. The x is here like that, okay? And the y is there like that. That's not the greatest. It's not bad. It's not the greatest sketch. Okay. So the sine of theta would be y over r, but now we've created a circle where r equals 1, so it's just y. So sine of theta just equals the y coordinate of that dot. This is the easiest way to get the general sine of theta. Likewise, the cosine of theta just equals the x coordinate of that dot. Okay, let's do an example or two. Okay, so D, example. Okay, so let's say we pick an angle down here. That means all the way around like that. Okay, so that's our theta, all the way around like that. Okay, and we'll say this is 240 degrees. Okay, that dot there, created by the angle, it's the dot on the circle that's at the end of like kind of the swinging door, okay, that has coordinates, x and y. I'm going to do the x one first because that's kind of the way we tend to think. Okay, there's the x coordinate. Okay, so cosine of 240 degrees equals, it would be adjacent over hypotenuse, right? It would be x over hypotenuse, x over radius, except we've now made the radius 1. This is a unit circle, radius is 1, so now it's just x. Makes it much, much easier. And it turns out, let's see, is x positive or negative? It's negative, and it turns out to be 0.5. You can see I'm picking the easy angles to remember. Okay, and likewise, if we do sine of theta, or sine of 240 degrees, that will equal the y coordinate, since the radius is 1. Okay, and that would be this. Also negative, and it's negative 0.866. Okay, from this idea of the unit circle, and from what we just said, that cosine of theta equals the x-coordinate, and sine of theta equals the y-coordinate, you can very quickly figure out many things about the trig functions. And we're going to do this very fast. I don't want this video to be too long. Okay, first, you can figure out the positive or negative sign of in each quadrant for each trig function. So sine is y, so it would be positive up here. Any dot up here would have a positive y coordinate. Any dot down here would have a negative y coordinate. And likewise, do the same thing for cosine. And cosine would be positive on this side and negative on this side. And from that, you can figure out the sine, plus or minus sign of tangent, because tangent is sine divided by cosine. So it would be positive here, negative there, positive there, negative over negative is positive, and negative there, and so forth. You can also figure out how a trig function changes as theta increases. So let's say I want 0, and we'll call these angles A, B, C, D. All right, as theta goes from 0 to A to B to C to D, sine is the y-coordinate, so you can see the y-coordinate, watch this finger. The y-coordinate's getting bigger, it's going from 0 to 1. Cosine is the x-coordinate, so now watch this finger, it's the x-coordinate of each of these. 1 gets smaller, smaller, but still positive, smaller, and goes to 0. And if we keep going, oh, now the x-coordinate's negative and getting more negative, so that's cosine going down to negative 1. Then cosine coming back from negative 1, negative 0.5 to 0, and then cosine entering the positive range, positive 0.5, 0.6, 0.7, 0.8, until it's positive 1 again. Okay, finally, I'll show you a tool I made for my students when I taught this in the classroom. I called this the paper calculator. Technically, it's actually a rule, not a calculator. It's like a ruler, and it's precisely drawn with a compass, a protractor, and a ruler. And it's got coordinate axes. The units are 10 blocks to a 1. So this is a 1. So it's a unit circle. It has a radius of 1 because each block is 0.1. And see, that's 0.5. And you may need to get closer to the screen or zoom in or whatever to see this better. Then I took a protractor and marked off every 10 degrees with also the 45s. So there. And so to figure out the sine or cosine of anything, like let's say we want the sine and cosine of 30 degrees. Okay, sine, there's the dot. You don't ever need to draw a line. All you need to do is look at the dot on the circle. There's the dot for 30 degrees. Sine is the y-coordinate of that dot, so you read over. Oh, it's 0.5. Sine of 30 is 0.5. Cosine is the x-coordinate, so you read down. And, oh, that's about 0.866. That's the cosine of 30 degrees. I have this in electronic format. I can email it to anyone who wants one.